Let's solve this quadratic inequality. This time we have the parabola is greater than 0. When we factor, we get x times x is x squared, and we have negative 2 times negative 3 is positive 6, and they add to be negative 5. But this time the parabola is above 0, above the x-axis. So let's sketch this parabola. We have 1, 2, 3, and we have the intercepts 2 and 3. So we have a happy face parabola. And when is the parabola? When is this boat above the water? Now it is true when we have a hollow circle here, we're towards the right of 3, or hollow circle towards the left of 2. So we say that x is less than 2 or x is greater than 3, not including the actual points, because this here is, there's no equal sign. Now recall that towards the left of this x-axis we have negative infinity, the smallest possible number, and towards the right we have the largest possible number, which is positive infinity. This set notation is equivalent to the interval notation. X belongs between negative infinity to 2, or, looks like a U, bracket 3 to infinity. Notice how we use rounded brackets for infinity because we can't actually equal this number. This is just an idea, not an actual number. Finally, using a number line, we have hollow circles at 2 and 3. And we're going to have the solution region extending to the left and to the right of these numbers. On the left we have negative infinity, on the right we have positive infinity, and the solution region is towards the left and the right with hollow circles. To solve this quadratic inequality, we should try to factor this trinomial. We have 2x minus 3 and x plus 6 as the factored form. And we understand the quadratic is above 0, greater than or equal to 0. So we have a parabola with critical points. 2x minus 3 equals 0. We have 3, so x equals 3 over 2, or 1.5. 1, 2, and it cuts through here, between 1 and 2. Whereas here, when we have x plus 6 equals 0, the critical point is x equals negative 6. We have 1, 2, 3, 4, 5, 6, all the way over here. We have negative 6. So this happy face parabola cuts all the way through from left to right. And when is the quadratic above 0? It is true either to the right or to the left of these critical values. So we say that x is less than or equals to negative 6. We copy this equal sign here and here. Or x is greater than or equals to 3 over 2. Let's solve this quadratic inequality. Be careful, we have the parabola here on the right, not the left. So when we sketch this parabola, and this is already factored for us, the x-intercepts are at 2 and negative 4. And let's draw a circle because we have a inequality without the equal sign. So these are hollow circles. This is a parabola, and we're interested in the parabola being less than 0. Looking right to left, the quadratic is less than 0. Do not accidentally think it's greater. So when is this happy face, this boat, underneath the water? It is true between negative 4 and 2. So x is between negative 4 and 2. Let's solve this quadratic inequality. We'll throw this negative 8 to the left. So the negative 8 becomes positive 8. 1 plus 8 is 9. So we have the statement 9 is greater than or equals to x squared, which is equivalent to saying that x squared is less than or equals to 9. Recall the pattern. We have variable squared is less than or equals to some number. What we do is we copy down that variable, and we copy down the inequality symbols, and we take the square root of 9, which is either 3 or -3. So this here is the solution.